I wanted to inject a little bit of reality into this online course, and to do that I thought, well, let's go down into the lab and see if I can show you how an echo sounder works. Now today when you look at an echo sounder, you might be lucky enough to have a transducer, a cable that you plug in, and then it's a box that shows you the echo sounding on a screen. But you don't actually see how the different parts work when you have it packaged in that way. So I collected the bits and pieces of an old system that allowed you to record the signals, and now we can look at those signals coming out, see what the signals look like, and then also print them, and I use the word loosely, print them on a chart recorder. So let's just see how the bits and pieces work. This is an old tape recorder. Don't really need to worry about the details, but out of it comes what was an echo sounding signal that was recorded, and a key pulse that's used to coordinate the timing. So I've got these guys plugged into an old school oscilloscope, and let's hit play. There we go. There we go. So signal's coming along, and here on the oscilloscope I have the key pulse. That's the bottom trace. You get a big spike and then nothing else. That just tells everybody when the echo sounder sends a signal into the water. On the top trace, you've got the signal that the transducer gets back from what's in the water. You get a big pulse near the beginning corresponding to the transmit, and then there's a bunch of clutter near the beginning that's associated with near surface backscatter, the mixed layer, and I even put the cursor on there. There's a pulse at around 12 milliseconds, you can see, and here, 12 milliseconds, there we go, the timer indicates that. It's telling us that you know, that first band, 12 milliseconds, near surface mixed layer backscatter. Over here, that's returned from the bottom. I know that because I kind of know the geometry of the situation, and so that's obvious. Big smacking signal probably saturates the receiver. In between, every now and then you see a little spike. It's probably a fish. You know, but the only persistent signals are that pulse at the bottom of the mixed layer, which is volume backscatter, probably from a cloud of zooplankton tends to collect there, and the bottom. And the stuff in between comes and goes before you have a chance to really say, hey, I don't know, what is that? So we need to create an image from these signals in order to, you know, keep track of them and make sense of it. And for that purpose, you need some kind of a chart device. So I send these signals over to this thing that's called, well, it was called the EPC. It predates thermal printers, and what it does is it has this band that goes along here. Let me get to zoom in on the band. There goes the band. It goes along, and on the band are these little fingers. You can see them here. So the fingers travel along the belt, go along here, and then at, you know, a well-defined speed, they travel along this piece of paper. And whenever a signal comes in that's big enough from the echo sounder, it puts, wait for it, a spark onto the paper, which makes a mark. In order to keep the timing organized, like there's multiple fingers, here's another one there, even though there's one on the paper right now. In order to keep the timing under control here, there is a little optical pickup here. Now, just let's pause and think. This is a device that works by creating a lot of smoke and soot. You'll get to see that in a second, which is very exciting, but it's also very dirty. Who in their right mind would put an optical pickup in this machine? I don't know. Later models had a magnetic pickup. Okay, so there we go. That's the device. I'm gonna turn it on now. Here we go. There we go. So So what happens is, each time the echo sounding comes in, you can see the sparks there. And it goes across on the paper. There's the bottom, big return. Now, it's showing me the same thing that the echo sounder or that the oscilloscope was showing us, but by moving the paper a step, each time a key pulse comes in, and the key pulse is also used to time where and when the trace gets made. Slowly, it starts to paint out a picture. And let me zoom in here. There's the bottom. And in the water column, you can see the little flecks that correspond to actual targets. Up here near the surface, there's that band of backscatter associated with the mix layer there. And at the very top of the trace, of course, the surface where the echo sounder is. So, here we go. Oh no, I ran off the end of the tape. So hang on, I have to rewind. Okay, so I'm running the printer again, the chart recorder, and starting to print things out. There, I see a school of fish. The surface. What else is there to say about this thing? Well, you might make fun of it and saying, oh come on, it's all analog. No, it's not. It actually has a 4-level print capability. So, you know, it's actually 4 shades of gray on the system. But the point I wanted to make here is that as the thing plays out, you slowly create an image, and that's really what we call an echo sounding these days. There's all sorts of different formats you could use, but nowadays the sort of standard, you know, basic echo sounder, you get the a trace, a recording of backscatter in the water, occurrences of volume backscatter which show up as a cloud, and discrete targets like that school of fish. Well, and of course the bottom that just comes booming on in. There we go. Turn it off and have some quiet. Okay, let's just like recap here. Surface, volume backscatter at the base of the mixed layer, some fish up in the water column, school of fish down near the bottom. As a convenience, we have these traces along the way. I think they're every 15 milliseconds to see where things are. Okay, we'll leave it for that. Right, I thought I'd collect together like a full image with some interesting stuff in it. It takes a bit of time, so I just did that while you guys were turned off. Okay, so same, you know, EPC chart recorder thing. Same actual data set, I just rewound the tape to a different place. And it was kind of, you know, useful to see, okay, you know, again, remember, transmit some, you know, volume backscatter. You can't really see the individual targets very clearly. Volume backscatter at the base of the mixed layer, almost certainly. Into the water column, you can see, you know, little hits here and there. You know, those are like targets in the water, hard to know what they are. Could also be noise. You sometimes get that kind of background noise from who all knows what's on the go. But then in this case, we have, you know, several schools of fish. Oh, and just to be clear, you know, there's the bottom running along like that. Schools of fish up in the water column, and also some other kinds of fish here, probably, you know, more like herring, you know, smaller fish. Whereas these guys here, if you look, you know, you can actually see hits on the individual fish, which is, you know, kind of cool. Yeah, so just to show a bit more clearly sort of the variations. And then, you know, when you collect a bit of data together, you can actually, stand back and, you know, get the image that you think of as what an echosounder is.